Welcome to another trainML tutorial. trainML is a GPU as a service platform specifically designed for deep learning. Our platform lets you get up and running on GPUs with just a few clicks without the need for managing servers, learning a new framework, or enduring a lengthy software implementation. In this tutorial, we will walk through how to automatically run a trainML training job to train the latest version of your model code every time a commit is pushed to the master branch of a GitHub repo and to store the results as a new trainML model version. To do this, we will use GitHub Actions to configure a workflow that activates on changes to the master branch. Our public GitHub workflow example repository has all the basics already built out. The model code in this example is an ImageNet training model copied from the PyTorch examples repository. The two key folders in this process are the .github/workflows and scripts folders. The scripts folder contains the run_training.py Python script, which is what actually creates the training job. The run training script has a create job function that takes a build serial argument and some main loop code that will run the function using the GitHub SHA environment variable, which is one of the default environment variables that is set in all workflow runners. When the workflow runs, this variable will be set to the commit hash that triggered the workflow. Within the create job function, there are several key settings to note. First, the script includes the build serial in the name of the job to make cross-referencing easier later. Since the output type of the job is a trainML model, this will ensure that the build serial also gets included in the resulting model's name. Second, in the worker command, the script prefixes the actual training command with an explicit git checkout of the commit that initiated this workflow. Since the script doesn't run instantaneously upon commit, there's a chance that a subsequent commit could be introduced between the initiation of the workflow and the actual creation of the training job. By explicitly checking out the commit as part of the job command, the script ensures its training is done on the right code version. Since this code is designed to run on ImageNet, the script also specifies that as the dataset to prepopulate for this training run. For the model specification, the source type is Git, and the source URI once again takes advantage of the GitHub default environment variables to determine the code repository path instead of hard coding the repository name. This ensures that the repository can be easily forked and the script will still work, as we will demonstrate shortly. One other thing to note, this example is designed for a public repository. For this to work with a private repository, you would need to replace the GitHub server URL with the SSH syntax. The GitHub repository portion would remain the same. Now that we have a script that will successfully start a training job, we just need to configure the GitHub workflow to execute it. This is what the .github/workflows directory is for. In that directory, there is a run_model_training.yaml file. This file specifies what happens when the workflow runs and under what conditions. In this case, it defines a single job called create training job that will run upon a push or pull request to the repository, but only if the branch is master. The job itself has several steps. The first pulls the repository and checks out the correct commit hash. The next installs Python. The third installs the necessary Python dependencies to run the training script itself. And the last part actually runs the script. A couple things to note here are first that the dependency installation step doesn't install the model code's dependencies, only the dependencies of the script we reviewed previously. In this case, the only dependency is the trainML SDK. This is because the GitHub runner is not running the model training itself, only creating the training job on the trainML platform. trainML will then install the requirements.txt file dependencies automatically when it creates the job and runs the model training. The other thing to note is the use of custom environment variables to supply the trainML SDK with the authorization credentials to run the create job function. This allows us to securely store the trainML API keys as GitHub secrets and provide them to the runner securely. The easiest way to demonstrate the process is to fork the example repository. When you fork the repository, the workflows are automatically disabled to prevent unexpected results. Click I understand to enable the workflow. You can now see the run model training workflow, but it is not run yet. Before the workflow will work, the trainML API keys must be configured as secrets in your new repository. Go to the Settings tab of the repository and click Secrets. Click New Repository Secret to add the trainML_user secret, and repeat the process for the trainML_key secret. The values used should be those in the credentials.json file that you generated when you created the trainML API key. Now that the workflow is fully configured, We need to pull the new repository so we can create a new push event. Add an empty file to generate a chain set, commit, and push. Back on the GitHub Actions tab, we can watch the progress of the workflow. When the Create Training Job step completes, it will output some of the details about the job it created. If we navigate to the trainML Training Job dashboard, we can see the job getting started. Once the job is running, we can watch the logs to monitor the training progress. When the training job is complete, we can navigate to the Models section to see the new revision of the trained model with the commit hash in the name. At this point, if we're satisfied with the new model's performance, we can use it in new inference jobs or endpoints going forward. As we've seen in this tutorial, trainML makes it easy to automate model training as part of a CI/CD pipeline. With just a few lines of code, we configured our repository to automatically train each revision of our model code and store the results as a version trainML model for later use. If you'd like to learn more, you can check out our documentation site at docs.trainml.ai or shoot us an email at sales@trainml.ai. If you run into challenges running this example or anything else, you can always contact us at support@trainml.ai. Thanks for watching.